You know that feeling, right? A powerful new tool lands, like BigQuery, promising all this speed, serverless analytics. It's exciting.
Oh, absolutely. Massive potential.
But then there's that nagging thought.
Hmm.
Are you actually getting the most out of it? Or maybe are you making some costly mistakes without even knowing?
That's it, exactly. BigQuery can be a total game changer,
Mhm.
but like anything powerful, you really need to know how to use it properly.
Mm-hmm.
And that's what we want to get into for you today. Think of this as a shortcut to getting it right.
Yeah, a rapid guide maybe? We want to focus on setting things up smartly right from the get-go so you can sidestep those, common traps that inflate costs or slow everything down later.
Precisely. We're going to zero in on the core things, the fundamentals that really shape your whole BigQuery experience. It's like laying a really solid foundation, get that right, and you're set up for efficient, cost-effective analytics.
Okay, so what are we covering? We'll definitely hit cost control, how to tame that BigQuery bill,
Mm-hmm.
practical stuff. Then performance boosters like partitioning and clustering, how they work, why they matter.
Crucial.
We'll also look at writing, cleaner, more efficient SQL.
Yeah.
And touch on data modeling, how it might be different for BigQuery.
Good one. That trips people up.
And finally, got to cover security essentials and smart ways to actually get your data into BigQuery.
And look, this isn't just tech theory. Doesn't matter if you're leading a data team or you're the engineer writing the queries day to day. These things matter, those
Right.
initial choices you make about how you structure things in BigQuery. They stick with you. They impact your budget, your speed, even your data security. Long-term consequences.
Okay, let's unpack that. Starting with the one everyone feels, cost. BigQuery charges based on data processed. So what are those early things people do, maybe innocently, that suddenly make the bills jump?
The classic one. It has to be select from a really big table.
Oh, yeah.
It seems so harmless, but you're telling BigQuery to read everything, even if you only need 2 columns. Do that often, especially on large data sets, and boom, costs climb fast.
Right.
Another big one is just not having any guardrails. No query quota set per user or project. No budget alerts configured. It's kind of like, leaving the tap running full blast without ever checking the water meter. You'll get a surprise eventually.
Yeah, it's not that the tool itself is necessarily out to get your budget, it's the way you use it.
Exactly. Inefficient use drives up cost.
Okay, you mentioned partitioning and clustering for performance. They sound a bit technical. Can you break down why they're so important, maybe what someone should think about right at the start?
Sure. So imagine a huge table is like one enormous, completely unorganized book, just pages everywhere.
Right.
Partitioning is like dividing that book into logical chapters. Usually you'd use something like a date column for that. So if you only care about last month's data, BigQuery just opens the last month chapter, ignores the rest, much faster.
Makes sense.
Clustering then takes it a step further. Within each chapter, it sorts the pages based on columns you often filter or group by. So maybe you often look for a specific product category within a date range.
Yeah, happens all the time.
If you cluster by product category, BigQuery can jump almost directly to the pages it needs within that chapter. Super efficient.
That book analogy really helps clarify it. It's all about reducing the work BigQuery has to do.
Precisely. Minimize the data scanned. So, practical tip. Always partition your big tables, probably by date or timestamp. Then think about what you filter on most in your where clauses. Those are good candidates for clustering.
Got it. Okay, speaking of wading through data, the queries themselves, we've all seen SQL that's, well, let's just say creative. How does messy SQL hurt you in BigQuery specifically?
Yeah. Well, in a paper query world like BigQuery, inefficient SQL hits you twice. Costs more, runs slower. Simple as that.
So beyond the select we talked about.
Right. Beyond that, a common thing is doing complex calculations or joins before filtering. You want to do the opposite. Filter first. Use your where clauses early to drastically reduce the data you're working with before you do the heavy lifting.
Get rid of the noise first.
Exactly. Also, be careful joining huge tables without filtering them down first. That can cause massive amounts of data to be shuffled around, which is slow and expensive. Oh, and for complex logic you run often, look into materialized views. They pre-calculate results, saving repeated work.
Good tip. Now, data modeling. Lots of us learned on traditional relational databases, heavy normalization and all that. Does that thinking need to change for BigQuery analytics?
Yes, big time. This is a key shift. In traditional databases, normalization splitting data into many tables to reduce redundancy is often the goal.
Right. third normal form and all that.
Yeah. But in BigQuery, especially for analytics, denormalization is often your friend. That means bringing related data together into fewer, wider tables. You might use nested fields like stress UTs or repeated fields like arrays within a single table.
Feels wrong at first? Maybe. A bit redundant.
It can feel that way if you're used to the old ways, but it avoids those expensive join operations across massive tables. Joins can be real bottlenecks in distributed systems like BigQuery. So if you find you're constantly joining, say, orders and customer tables, maybe think about denormalizing, putting key customer info right into the orders table for your analytical use case.
Interesting. So sometimes making the table structure seem a bit messier actually makes the querying cleaner and faster.
You got it. It's optimizing for how the system reads data.
Okay, let's switch gears to security. Obviously crucial when you've got potentially vast amounts of data in one place. What are the must-dos from the start?
Foundational principle, least privilege. Always. Use IAM, that's identity and access management, carefully. Don't just hand out broad editor or owner roles at the project level unless absolutely necessary.
Give people only the keys they actually need.
Exactly. Grant permissions specifically for the task they need to do, and dive into BigQuery's own features like row-level security and column-level security. They let you control who sees which rows or columns within a table. Super powerful for protecting sensitive data. Implement these early, don't bolt them on later.
Makes total sense. Okay, last technical bit. Getting data in. Any common stumbles during data ingestion?
Yeah, a couple. One is trying to stream data in row by tiny row when batch loading would be better. BigQuery loves bulk loads, aim for batches.
Right.
Also, file format choice matters. Columnar formats like Avro or Parquet are generally much better for analytics than row-based formats like CSV or JSON. BigQuery can just read the columns it needs.
Less data read, less cost, faster queries. It all connects.
It all connects. And finally, understand the difference between streaming ingestion for near real-time needs versus batch loading for bigger, less frequent updates. Pick the right tool for the job.
Okay, great practical advice. So, stepping back, for leaders listening, the people making the strategic calls on data tech,
Yeah.
what's the main takeaway here about BigQuery?
I'd say it's that BigQuery's potential is huge, truly transformative for handling data, but realizing that potential, it really hinges on getting the implementation right from the beginning.
It's not just flicking a switch.
No, not at all. It needs strategic thought, proper planning, and frankly, the right expertise. Investing upfront in designing a solid architecture, whether that's developing your team or working with experienced partners, firms like Curate Partners who specialize in this stuff, that investment pays off. It prevents major headaches, later cost blowouts, slow performance, security gaps.
Right, planning prevents pain.
Yeah.
And for the data pros, the engineers, the analysts actually building things.
Yeah, understanding this stuff is a massive career plus. Being the person who knows how to optimize BigQuery, designing tables smartly, writing efficient queries, setting up security properly, that makes you incredibly valuable. Being able to talk intelligently about BigQuery optimization, maybe in an interview or a technical discussion, that definitely makes you stand out from the crowd.
So wrapping up, as you, the listener, think about your own BigQuery setup, or maybe you're considering adopting it.
Yeah.
Remember that building it thoughtfully and querying it efficiently, those really are the keys. Get the foundation right.
Absolutely. There's always more to learn, of course, but nailing these fundamentals we discussed, that sets you up for a much, much smoother ride and lets you really leverage the power of your data.